Okay. Looks like we're pretty much good to go. Let's take a brief look at my notes here. So the plan I have in mind is to try to get through particle systems as our next major topic over the next day or two. Probably can't get it all done today. And then after that, I'll do a little bit about the GUI system oriented toward some practical aspects that may be useful for helping you add a tutorial to your projects. And at that point, I'll be ready to give you our last lab and pretty much turn things over to Michael to go the rest of the distance here. Okay, so right. So let's talk about a little bit about what particle systems are. Some of you probably know all too well. Some of you have already been using them, but I don't know how much you've actually thought about them or peered under the hood. So let's do a little bit of that. The idea of particle systems is it's really a very they're very flexible Swiss Army knife kind of tool that really have dozens of applications, and it's really the kind of thing that's just limited by your own creativity. But technically, they all have a common foundation. So it's basically there's some it's the entire phenomenon is made up of one small piece that's kind of repeated and repeated and repeated according to some rule. And we'll get into all the different ways you can set these things up, and there really are quite a number of them in Unity and pretty much in any other system that has them as well. Okay, so again, so it's the whole effect is made up of a number of small elements that are basically the same in some sense. So maybe that makes sense as to why you might be able to do smoke with that, for example. I mean, smoke is a cloud of smoke could be built out of a bunch of small puffs of smoke, right? And that's in fact exactly what we do. Fire, a similar way, though it's a little more tricky, and to get really good fire, you maybe need to go a little more advanced. Mist, same story as smoke. Foam, here I'm thinking of foam on the wave tops or something like that, or kind of a surf effect. Blood, bullet casings being ejected from a weapon are also often done with particle systems, and a lot more. I missed a lot of obvious ones actually. How about rain? How about snow? How about leaves falling from trees? Okay, that's one I kind of tend to leave out. How about dust? Just like little motes of dust, which might sound like a dumb thing to put into your level, but you'd be amazed how much more alive it makes it seem. Even if you have a picture, you're gazing out at on a windless day at any scene, pretty much. We tend to think that, okay, well, if nothing there is actually, nothing big is moving, nothing's moving, but in fact, there's usually almost always some kind of motion, if only from motes of dust moving in the light, if only from leaves falling down from the trees or something like that, or tiny bits of dust being whipped up by the wind. So all of these things are good candidates for the use of particle systems if they're properly configured. Okay, so it's a great tool, but to allow them to do all the different things that I said, there's definitely a downside of it too, right? Which is a very typical downside for things in computer graphics. So it's like, hey, you got some really capable tool. That's awesome. How long is it going to take me to learn to use it? Because if it's very powerful, it probably has a lot of things that require specification, and I might actually have to practice with those things to get any good at it. and particle systems are in that category, at least for me. Whereas a lot of other things in Unity, you know, so we pushed off all the complexity of, you know, building detailed 3D models, of course, of building animations. We didn't talk about that at all. All of that we know, oh yeah, that would be a job for a Blender, a 3D Max, a Maya, some other tool that's going to be like a whole nother big project to learn. Okay, so Unity, they have Pro Builder, but I don't think they really want to go replicate everything that's in Max or Maya. Okay, I don't think that's going to happen. All right, but there really isn't a kind of a standard tool outside of a game engine to build particle systems. So usually game engines are in the situation that if they want a nice infrastructure for particle systems, they pretty much have to build up their own custom infrastructure for producing the particle systems in real time, and also for supporting the building of particle systems, okay? So it's one of the more technical things, I think, that is really part of using Unity proper. Now, you can't expect that you can have someone, you have a friend, an employee, a contractor who's great with Blender or great with Max, unless they're also a Unity person. They're not going to give you your particle system, you know? Someone who's good with Illustrator or Photoshop, more likely, might be very helpful for particle systems because they would give you a texture that you might need to build the particle system. But unless they know Unity, that's going to be on you, all right? Or on your Unity guy, since you guys have graduated. You have a team of people. It's going to be the Unity guy that's going to have to do this, the game engine guy. Okay, now, one of the issues about particle systems is that you almost, so it's the big phenomena is made up of many little parts. And the next question is, how many? And the question after that is, and then how exactly do you deal with that? Okay, and the answer to how many is almost more is better. For almost any of the particle system types that I mentioned, you really would like a large number of particles. Certainly for things that are trying to imitate a continuous phenomenon, right? Like a cloud of smoke actually isn't 100 puffs of smoke. You know, it's actually a continuous distribution of the smoke. So for things like that, if instead of 100 puffs of smoke, you could use 1,000. If instead of 1,000, you could use 10,000. You know, probably what you're seeing on the screen is going to look nicer and nicer, again, with proper configuration. Okay, so, all right, so if you're going to need 10,000 and up, so it's not unheard of to have particle systems that can use, you know, even hundreds of thousands, maybe even 1 million these days, particles just to produce one effect. So how do you actually deal with that technically? Now, this is maybe a good point to interrupt myself here and say that, okay, a caveat, as with the overall rendering system of Unity. So the rendering system that we've focused on for this course is just one of 2 rendering systems. There's another path that is, I think, less user-friendly, but also more capable, more appropriate if you're really trying to build something in Unity that looks absolutely top quality, okay? And it could be we'll be teaching that in the future, but it kind of raises the bar. I mean, the way we're teaching Unity this year, you know, anybody with almost any laptop, any modern laptop, should be right at home. Okay, once you switch to a more top shelf kind of a infrastructure, now you need a real graphics card. You know, even so, my laptop, which I consider decent, maybe not the best one in the class, but probably toward the top end, is not going to cut it. You need something that's a real, like a gaming laptop, or just forget about a laptop and go to a full desktop system. Okay, so that's uncomfortable. So that's why we're not really going down the path of the second rendering system at all. Now for particle systems, there's a similar split. So if you start reading the documentation, you'll realize there's a visual effects path, which is more GPU based, which again, if you're really trying to be absolutely top shelf, you really would owe it to yourself to take a look at that path, but you're going to need a decent graphics card. So we're going to go with the more traditional version, which is still there, still heavily used, quite capable for a lot of things, certainly for the learning. That's where we're going to be. Okay. All right. So we're not going to be using the awesome power of the GPU. This is going to be yet more work for our CPU, which is already pretty busy doing a normal game. So how are we going to deal with 10,000 droplets of rain? Okay. Be a particle system to represent my rain. Okay. So the way to do that is we're clearly going to have to be very careful. You're going to have to make sure that each droplet of rain is as absolutely lightweight in terms of memory use and computation use as possible. Okay, and you're also going to want to recycle your particles, right? So a drop of rain starts falling from the top of the screen, goes toward the bottom, hits the earth, maybe goes off the bottom of the screen, maybe. Either way, you're done with it at that point, and now you could reuse that little bit of memory and that little bit of computation to make a new droplet of rain, okay? So that is the model that's typically used. So their particle systems are typically stored in what is often called a circular buffer. So that would be, it's like an array, but where it's understood when you get to the last element of the array, you know, the one at length -1, right? Then the very next one, there's always a next element. So the next one after the length -1 element of your array is the 0 element, and around you go, okay? And typically, particle systems, once a particle has been around for a while, so there's some philosophy here. I have to talk about this a little more than some other things. There's some philosophy behind it. The typical idea is the particle's most important shortly after it is created. That's the idea. So drop of rain, I'm not really sure that's really necessarily true for, but a lot of other cases, like a little puff of smoke that's getting produced. I mean, what's going to happen to that puff of smoke over time, right? And think of a real cloud of smoke, right? Any little, if you focus on some little patch, I mean, it's not just going to hang around forever, probably, right? I mean, it's going to get more nebulous. It's going to probably float up. One way or another, it's either going to float out of the scene or it's going to become so nebulous it might as well not be there. Okay, and that's kind of the poster child for the general expectations of a particle. After it's been there for a while, it's less important. So the way the circular buffer recycling happens is that once you need the next drop of rain or the next cartridge casing to place, you know, in the air immediately above your weapon, because I just fired my weapon, the particle system is not shy about just grabbing and recycling an older particle to give you the new one that you just asked for. That happens by routine, okay? And what this means is that if you have a good eye, you can literally see this happening, okay? So you're probably aware, you know, if you've played more games or simulations, you're probably aware that something like cartridge casings, no, there could be a whole lot of those after a firefight. Does the game really keep all of them around forever after they're produced? Yeah, you're probably aware if you've seen this enough that it doesn't actually do that. I mean, despite the fact that it's not realistic, if you look at one of them on the ground, after a certain point, you will see often that it fades out or sometimes that it just blinks out, okay? And the way this particle system recycling works is that once we get, you know, I asked for a next cartridge casing, right? Because the user just pressed a button, I need to shoot, okay? If that next cartridge casing slot in the buffer has never been used, awesome, in which case it's just going to give me a new one, that's great. But if that cartridge casing that corresponds to the next slot in my circular buffer is there on the ground and it's visible, it's just going to blink out of existence, okay, in order to give me the new fresh one that's coming out of the gun. Okay, so you got to be aware of that. So this means that, you know, if you really hate that effect, that means you want your circular buffer to be as big as possible, right? But that means you're going to consume more memory. So nothing here is for free. If you want your particle systems to be nice and cheap, that means you'll be stingy with your circular buffer, and then you'll have more of this visible blinking out and recycling of the particles. So be aware of that as we look at some examples to see if you can actually see it. I think when a particle system is well put together, it's pretty hard to notice, but not impossible. Okay, the next thing that's a typical thing, but not absolutely always these days, is that particle systems usually are 2D. I mean, they're really just a picture. So like the traditional way, even for something like a particle, a cartridge casing, would be to actually like have a picture of a particle casing, of a cartridge casing, not an actual 3D object. A cartridge casing is really a very difficult case for that. It really kind of sucks. So that's why I'm saying they're usually 2D. These days, it usually is possible by checking a box and doing some extra work to have your particles actually be 3D objects. Okay, but let's leave the cartridge casings on the side. For everything else that I said, a drop of rain, a puff of smoke, it's much more credible for all of those that, yeah, you could maybe do that just with a 2D texture, okay? So literally we call these billboards because like a billboard, they're actually just a flat picture. Now, billboards in computer graphics have the connotation that they're always going to be, or well, usually are going to be facing toward the camera, okay? Because I mean, if your drop of rain is allowed to face any possible way, what if it's facing away from you? So you probably know a texture from the back is invisible. Or what if it's facing away from you at a sharp angle, so it's just barely visible? It might not even look like a drop of rain. So the general way these are used, the classic way, is that each drop of rain, yes, it's a little square picture of a drop of rain. Now, granted, around the droplet, probably the rest of the square image is almost certainly going to be transparent. You know, it's not going to be obvious that it's actually a square thing. Okay, so you're just going to see the shape on the inside of the drop of rain or puff of smoke or what have you. Okay, but that picture is always going to be facing directly flush toward the camera. But there are variations. That's not always, and I'll show you examples where that's not true, even in my very limited coverage that we're going to do, okay? But another possibility is that that they don't literally face square on with the camera, but they're rather always so they're like posters, they're like campaign posters that someone puts up in their yard, okay? So like the post is always going to be vertical to the ground. Okay, but you could imagine that the poster is still allowed to turn around the y-axis to face kind of toward the camera as best it can, given that the y direction always has to be fixed. That's another fairly typical use. I would feel comfortable calling those billboards as well. I don't know about other people. Okay. Any questions about this? It's all kind of been nebulous philosophy. We're going to start getting technical and detailed and hopefully get into some examples real quick. But any questions so far? Okay. All right, so let's do some terminology. So there's some notional things. So the particles have to originate somewhere, right? So I mean, if it's drop of rain, they're going to originate from maybe a plane above your screen. If it's some smoke, well, it probably originates. That means something's burning. There's a point where that fire is, a point or a region where that fire is. Okay, so the particle comes from somewhere, and that region is called an emitter. Okay, so the emitter's job, just in general, and this doesn't exactly square with the terminology in Unity, but almost close enough. And you know, because every game engine uses slightly different terminology. So there's at least a couple different aspects to emission of the particles. One would be the shape of the origination zone, right? Like I said, the rain comes from a plane. The smoke comes from a fire. It may literally be a mathematical point. Probably that's not going to look very good. It's probably going to have to be, maybe it'll be a spherical region, or maybe it'll be a disk, okay? So there's some shape involved. The next thing that should be involved is some kind of an initial velocity, right? So for rain, it should be falling down. For smoke, it should probably be born almost motionless, right? And then maybe start drifting up, okay? And for each type of particle, there'll be a different way that will give you the best visual look, the most realistic look of setting the initial velocity. Okay, so that's step one. Okay, so now we've got our emitter set up, so our particles are born. Great. The next thing that is almost always, you almost always need to do is deal with the variation of various properties over time. Again, there's more that could vary over time than is in my list, but like the three main things that I've seen varied is one, the size of the particles, okay? So for example, typically as they're getting older, they're getting bigger. And this relates to things that are smoke-like, right? A puff of smoke, can be born small, but what happens to a little puff of smoke? Again, it gets bigger and it gets bigger over time. Secondly, the speed. Okay, so something like, an ejected casing would be an example of that. It may start out, or I should, instead of speed, I maybe should have said velocity. I mean, it may get ejected from the gun at one angle, but then it needs to fall to the ground. That's one possibility. Rain would probably fall at a steady rate, same with snow. Drops of blood might accelerate a little bit visibly as they get toward the ground. I'm not sure. Okay, so that's the next thing that you might change. And the third thing is the color and or the opacity of the particles. So a puff of smoke should get more transparent, i.e. less opaque over time. Okay, and a spark. Oh, I didn't mention that before. What about sparks? That's another great use case, right? So metal grinds against metal, or you shoot and your bullet ricochets off something metal, or probably more use cases than that. Baron, do you have a question?
No, sorry. Do you expect us to see only your slides, or are you just
yes, at the moment, yes.
Okay.
Yeah, sorry about that. It's
just
it's so inconvenient to go back and forth. I'm sorry, it's a lot of words to get started, but yeah, well,
okay.
there will be more than just words before we're done. Sorry about that.
Thank you.
So good. And actually, since you mentioned that, and I am getting toward the end, let's actually start up a project, because I don't have one for particles yet. So I'll take a little break here and get one going, and I'm going to want my standard assets in there as well, and you can do the same if you want to follow along. Okay. All right, that started. Let that cook for a bit. Okay. Where was I at? Oh, sparks, right? Think about the example of sparks. So sparks are liable to be born white hot, but as they cool, they're likely to maybe get yellowish, and as they get really cool, they may get reddish. If they get completely cool, they will get, very dark brown to black. Okay, so you might have a whole spectrum of colors that your particles go through as they age. Okay. Right, we're good here. I'll skip the new version. Let me pull in my standard assets here, and I'll finish up my slides, and we'll get started with something more visually interesting than my slide. Okay. All right, let you get going. Okay, good. Okay, so again, there are other properties you'll kind of see. You can, the good thing about Unity is it's not going to be able to shelter you from specifying all these things, because how does it know what you want? But it at least has them well organized, and they're kind of in a list, and you can kind of just go down and deal with the ones that you think you need to deal with. Okay, let's see now. Last thing I want to say is just that there are, so now that I've told you what particle systems are, now I want to hedge and say, well, but people do all kinds of things toward the boundaries, and I've dealt with particle systems in more than one game engine, and they all have certain things that are kind of unique to that game engine, or that go above and beyond the very traditional capability that I've been describing so far. Okay, so one of those things would be if you really want to have good fire. If you really want good fire, it's very hard to do it without having texture sheet animation. So texture sheet animation, what it looks like is you load in textures to Unity. And if you look at the texture, it's very obvious that the texture is broken up into tiny cells, and each cell is like an animation cell, like for a traditional Disney movie or something, okay? Except for building fire, it would probably be an animation of a flame, okay? And then what happens is Unity, I haven't actually done this. I would presume they do whatever is reasonable on their side to help automate the process so they can go in and break that thing up for you. And then the idea would be frame by frame by frame, as the particle advances through its life, they will take each successive images from the texture sheet, okay? So the particle won't just be a little red blob, which might have property variation over time, but it's always basically the same little red blob. No, it's actually always going to look like a flame because it is an image of a flame, and the flame is going to flicker over time the way a flame really does because, well, I guess it all depends on the quality of your texture sheet. But if you have a good one, that would be what you'd expect, okay? And the last couple of items here are, it's also possible to put physics into a particle system. Actually, physical forces is actually not so special. Almost everyone does normal physical forces. So in other words, the ability to have gravity accelerate the particle toward the down direction. That is a very normal capability. A little more toward the edge is collision detection for the particle. So for example, for sparks, so sparks should probably bounce off of surfaces, right? So there's some ability to do that in Unity. I've never pushed it to the edge. I don't actually know. I know for a fact, because I've done this, you could have your sparks bounce off the ground, or your cartridge casings bounce off the ground. That I've done. To have it bounce off just everything that has a collider on it, maybe, but also maybe not. Okay, so yeah, so already too many words. Are there any questions at this point? We're gonna jump into Unity and do some hands-on stuff. Okay. All right, so here we are in Unity. I should have my standard assets loaded up. That's great. Okay, let me go and do this. Let me put down a ground plane. Okay, and let's scale it so it's reasonably big. And let's just try. I haven't done this for a while. This is a little bit dangerous. Let's see. Let's just add a particle system directly from the menu. I haven't actually done this for a year. Watch me get in trouble now. Okay, well, there you go. So there's an example of a particle system. So what do you see? Right? You see that, oh yeah, it's just made up of a lot of little white blobs, right? They're all exactly square, okay? If I move my eye around, they're still square. If I move my eye to the side, they're still square. I mean, how is this possible? Well, yeah, because they're not actually like flat pieces of paper floating in 3D space, because then we'd be able to get around behind them. They are billboards, and as I move the camera, they are turning to face the camera. That's what's going on. Now you do notice, doesn't look like they're all exactly the same size. I'm hard pressed to say. Okay, let's see what we can find out. So if we just have this, so here's a generic particle system. You see you've got a little control here where you can stop the thing and play it again. Okay, I'll just leave it playing. Then we can look at the inspector and, oh, the horror. Okay, so all this stuff here, you see under particle system, all this stuff is stuff you might have to deal with, okay? And if that looks like a lot, it's more than you think, okay? Because these things down below, when you click on them, they open up additional panes, okay? But the good news is that, as with this one, you see emission is checked, shape is checked, renderer is checked, and nothing else, okay? So let's just, this is as good a starting point as any. Let's see what we can learn about what goes into a particle system. Okay, all right, so what do we have here? Okay, duration 5 and looping. So let's turn off the looping, okay, and press play down here. So 5, I think, is the total time the particle system will live. I assume that's 5 seconds. Yep, so there you go. Okay, so the emitter stops emitting particles after the duration, right? So this is great for some effects, But clearly for others, you need it forever, in which case you want the looping on. Okay, now notice when you play this thing, it starts from nothing. Okay, so if what I was doing here is I've got a little animation and my character is starting a fire, right? Like right now, then I press this and the smoke starts coming up from the newly born fire. That's perfect. Okay, now in other cases, so let's say no, that's not the case. It's my game is on a battleground, and from the opening scene, a battle's just taken place and there's smoking wreckage everywhere. Okay, so it would look really dumb if the camera comes on, the user sees your beautiful scene, and now the smoke just starts to come curling up from all the destroyed tanks and other things around. Okay, that's going to look wrong, right? So there is a notion, I think that's what this pre-warming is supposed to do. Let's see how good it is. So if we stop, press play again. Okay, now you see that it just kind of, as soon as I press play, the whole column of smoke is there. And it's not doing anything magical other than kind of starting it early before I say start. It starts it, but with all the particles kind of called out so nothing's visible. And then when I say go, it immediately springs to life, fully formed. So that's what the pre-warm does. Okay, you could have a start delay. I think it's pretty obvious what that would do. Start lifetime, I will say that is not obvious what that does. Lifetime seconds, particle will die. Okay, so it looks like each particle is supposed to have a 5-second lifetime here. That's interesting. Let's see if we can verify that. Okay, so if you play, okay, now the particles are getting off the screen before they die. Let me shift the camera up, so we'll give the particles more chance to. Okay, well, they still look good. Okay, let's go to the start lifetime and let's crank it down. Okay, how about we just make it 1.5 seconds? Okay, so now you see they're winking out long before they get to the top of the screen. Okay, so that's our start lifetime. Okay, start speed. Okay, so you see they're getting, that's this initial velocity thing. So they're getting shot up with a velocity of 5. What if I lower that? What if I want to have it be 1? Oops, I made it 15. Okay, well, we see what happens when it gets higher. Okay, so there's just having it be 1. So now you see they're winking out before they get to the top. Well, they still have the same 5-second lifetime, but if you're slower, you know, you're going to get less far before you disappear, right? Okay. All right, just put it back the way they are. Okay, 3D start size. Yeah, so it lets you start size separately for each axis. I'm gonna leave that alone for now. 3D is a little more advanced anyway. Okay, so here is the initial size of the particles. Okay, I think it's pretty obvious what that does. Let's make them bigger. And there you go. All right. 3D start rotation. Again, I'll leave that alone. 3D stuff is maybe a little beyond what I can easily show, but invite you to play with that for more advanced effects. Yeah, so you might also have the particles have some starting rotation. Okay, not everything is a perfectly symmetric blob. Okay, like these white blobs here, and if they're not perfectly symmetric, it may look dumb to have them all have the exact same orientation. So let's see, start rotation, but of course this is just gonna, this isn't gonna actually mess. This is actually just gonna start them all. This actually doesn't deal with the issue that I just said. So if you wanted them rotated over on their side, that would be more the issue. Let's say the rain is going to look like streaks, okay? But when you load your texture in, you see the streak. Well, the streaks are on their side. They're not going top to bottom. Okay, then this would probably let you flip it over. Let's play with this. Okay, 90-degree rotation. Of course, we can't even tell anything happened. Let's do 45-degree rotation. Okay, now there we can see. Now the particles look like diamonds, right? But the actual look of them, since they are symmetric and circular, doesn't really change. So this is not something, a great example of something that I think it's easy to imagine how it could be useful, but it's completely useless for this particular example. Okay, flip rotation. If you have spinning, this would let some particles spin the opposite way. That's interesting. Huh. Okay, well, let's see if we can get them spinning and then we can maybe play with that one. Okay, start color. Okay, what color are they born, right? They're supposed to be red, easily fixed, right? All right. Gravity modifier. Okay, so these are things are not affected by gravity. If I and particles would typically not be fully affected by gravity, but here you see we can have them affected by gravity to the extent that you want. If they're affected by gravity, but kind of like dust. I mean, we all know dust does settle over time, but it takes a good long time. Maybe just some really slight value for gravity, like that. Okay, you definitely see them arcing over, right? Okay, simulation space, that one I don't know. Interesting, some kind of control over the transforms. You can play with simulation speed. I'm guessing that this is probably most important if you're doing a texture sheet animation type of particle. Yeah, I'm not sure what delta time really does. Yeah, I invite you. These things, there is some coverage in the manual, but it is less than you might desire. It's less than I desire. So I have not ever learned what all of these things do. And for some of them, I think you might have to do some Googling or maybe some experimentation to figure it out. Scaling mode, okay. You know, the intent is clearly to be hugely flexible, but for some things, like that scaling mode I just looked at, I get what they're talking about. So somehow the particles are going to be in some kind of a hierarchy, and then if you scale something lower in the hierarchy, everything else is going to scale with it. If you're in a particular scaling mode, I kind of get what that is, but if you ask me, well, what is that useful for? I couldn't tell you. I can't imagine. Okay, so a lot of these things are tools that are only as useful as your imagination makes them useful. Play on awake. So yeah, so this is the same story as with the audio. You remember, or with an animation, play on awake. Some things you're just going to want it going as soon as the scene starts up. Other things should only be going when an event happens. Emitter velocity. I'm not sure what the intent of that is. Okay, max particles. Okay, so this is a pretty key one, right? So this is going to control how many particles you can have on screen at once. Looks to me like what I'm actually seeing on the screen is, I don't even think I can get 100 of these things at once. But if I give them, so if I really want to tap through and see what 1,000 can really get me, let's try to put the pedal to the metal here. Okay, let's give them maybe a longer lifetime. Let's give them a slower starting speed. Okay, and then you can keep messing with that. Now, I still don't think I have anywhere close to 1,000 here. I'm going to make the lifetime twice as long. I'm going to make the starting time even smaller. Okay, now I could believe I'm getting up into the couple hundred range. Okay, but you're still what's happening is the particles are just kind of winking out, I think, at the end of their 20 seconds of life. And I don't think I'm getting close to 1,000. Okay, so let's go the other way, okay, just so we can get a feeling for what this thing does. Okay, 1,000 is a lot. So let's say, no, I'll give you a budget of 10. That's ridiculous. But it'll give you some sense for how this thing works. Now, I'm really surprised, actually, by what I'm seeing here. I would expect recycling to be going on like mad. It seems like it's actually letting the particles get to the end before new particles are born. Okay, that's really interesting. Yeah. I wonder if this has always been what Unity does. It certainly is not what other particle systems I'm aware of do. Most of them do prioritize the recycling of new particles. This is clearly not doing that. It's doing the opposite. It's saying, you want new particles? I don't have any right now. You don't get any. So it's just waiting until the new particles are available to spawn them in. So that's pretty interesting. So be aware of that. Okay, we got a auto random seed. Okay, I think that doesn't do all that much for us. Rules about destroying the particle system. Rules about simulating the particle system when it's off screen, when the user's not looking at it, right? So this kind of a particle system could be a big computational expense. So do you really want the full foam on your waterfall when the user is looking completely away from it? And maybe you do, because you find out that, well, if I don't do that, when the user looks back real quick, he gets an unpleasant surprise and the waterfall looks different. Could be you decide like that, or it could be you say, no, my frame rate's just barely passable. I definitely don't want to waste the cycles. Particle system here. All right. What else have we got? Culling mode. All right, here we go. Continue simulating the particle when it's off screen. So like if the particle drifts off the top of the screen, right? So this is going to tell you, if you say no, don't bother simulating particles that are no longer visible, then again, you might have side effects to that you don't like. It certainly will save computation, but that means that the column of smoke that's going up in the air, it's going to look beautiful, but as soon as the user tilts his head back to see the top of the column, it's not going to be there. So as he looks at the top where the top of the column should be, it gradually will get filled in, but that's going to be a pretty weird effect and almost certainly not what you want. Okay, let's see what this says. Ring buffer mode. Rather than dying when their lifetime has elapsed, particles will remain alive until the max particles buffer is full, at which point the new particles will replace the oldest. Oh, that's interesting. That's still not the traditional mode that I had in mind, but that gives you some additional flexibility. All right, so it'll just let these particles keep floating up into the air. Let's try one of the other modes. Oh my gosh, okay, so there we are. So now you're going to get to see what 1,000 particles look like, right? Because it's literally going to leave them in until it needs the 1,000th particle. Okay, that's very interesting. Right, go back to the default. All right. Okay, let me just pause for a second. Any questions on these basic settings? So these are always going to be, these are considered settings that are been put front and center. Well, from my limited experience, I can see why. So you certainly want to understand most of those, I would say. All right, let's look at the next ones. Okay, I'm just going to focus on the essential ones for today. We'll do more advanced stuff tomorrow. Okay, so emission. So here we're talking about the emitter, right? So here it's talking about how quickly the emitter emits particles, right? So if I go and I turn it way down from 10, let's turn it down from 10 to 1, or from 1 to 0.1. Okay, now I've only got 2 particles on the screen, right? So you have the basic rate over distance. I don't think I've ever used that. So that's for emitters that are maybe linear. Emitted per distance unit. Okay, now you see it's turned off here. Let's look at the next thing down. Okay, so we got an emitter, we've got a shape. Okay, so the shape is a cone. Let's try stopping this thing. So there, down at the bottom, you can see a visualization of the cone. Okay, so what this really means is, what I've learned is that what this really means is it's not actually, so first of all, they don't mean a whole cone, right? What they mean is a section of the cone, from some lower point to some upper point. And the cone doesn't actually come down to a point, neither does it extend to infinity the other direction. Okay, and they don't mean that particles will be born everywhere inside this 3D shape. Where they'll be born is at the bottom edge of the cone, which is, of course, a circle. They'll be born down here. Okay, and what this visualization of the height of the cone is for is it usually reflects the something about the velocity. I think if we go up, let's see, we mess with the velocity, start speed over here. Okay, let's mess with this and let's see if the cone visualization changes. That will tell me if I'm right or not. Okay, look at that. So if you start with higher velocity range, you get that kind of a shape, a lower one, you get that. So that's what the vertical of the cone is for, okay? All right, what else do I want to say about that? Okay, well, cone is only one possibility. That's the next thing. You want a sphere? Then go for it. A half sphere, a donut, a box. You want to have like even a whole mesh. I've never done that, but you know, knock yourself out, give it a try. Circle and edge, okay? So here, if you have an edge as the emitter, then it might make sense to have a number of particles per unit length. Let's actually try that. Let's go in, let's play. So they're now going to be emitted from the edge. Well, that's interesting. Now the emission direction totally changed too, so I'm not too keen on that. Oh, well, that's because that's the Y direction, isn't it? Okay. All right. Well, that's fine. This would be here's kind of a foam effect, right? Something that could be almost looks like a flood of water going by there. Okay, cool. Let's actually go in the emission. This is what I wanted to do. Let's play with the rate over distance and see if we can see if it changes anything. Let's turn this one down, and then let's try a big and a small number down here. I'm not really. I think maybe I guessed wrong. I'm not seeing a big change. Okay. All right. So I actually don't understand rate over distance. All right. But you see, it can be emitted from a 2D edge, as well as most of these things are going to be 3D. Well, rectangles. Well, edge is 1D. What am I saying? Rectangles 2D, circles 2D, or maybe 1D. Actually, let's put a circle in there. Yeah. Okay. So you see, they said circle. It looks like they mean disk, right? Emitted all over the disk, not on just the 2D outer edge. Hemisphere. Okay. All right. So what else do I want to say about this? Yeah, each shape has different parameters, as you might expect, that you're going to need to specify. You can set the scale, rotation, position. You can also just use the normal widgets to go rotate it around or scale it. So you can do it with the widgets instead of by typing in numbers. Yeah, so that's your basics of shape. And last but not least, since we're at the end of the hour, take a little look at the renderer. Okay, so the renderer has quite a number of possibilities here. We can go over a few of them. So billboard you see is the basic one, but mesh should allow you to bring in a 3D mesh, even though I've never done it. Okay. Normal direction. Okay, so this talks about whether you're going to have camera facing or something else, but I don't see what something else exactly would be. Okay, you typically will have a material, right? When you use a texture in Unity, it's going to be bound to a material. Same thing here. Okay, so you've got a material loaded in there. What else do we have? Some particle size parameters. Allow roll, not really sure what that does. See if there's anything here I know is important. Oh, casting shadows or not, right? So like with a cartridge casing, you probably want them to cast shadows. Ordinarily, you've got a lot of particles and shadows are expensive, so you probably don't want them to cast shadows. Receive shadows, that's the opposite direction, right? If something comes between your light source and the particles, should you be able to see the particles are darker? And I think that'll do it for today. Questions on your guys' side? Okay, we need to go over more of these boxes than we've done. So sorry, I realize this isn't the most exciting thing, but it'll get more interesting as we go along, and we'll work up to some, we'll at least take a look at some good examples that really look like something more than a bunch of little white cotton balls. Okay. All right, I'll see you guys tomorrow. I'll come back on in a minute after I start the recording conversion process.